So thanks everybody for joining. And this workshop is about developing and deploying ML projects using open source tools called Metaflow and Seldon. And just to give you a quick overview, like what we are about to do today, Metaflow is an open source framework that originally started at Netflix, that was open sourced 2019 and is now used and developed actively by hundreds of companies. And Metaflow especially covers questions related to how you build models, how you prototype models, how do you structure these data science applications as workflows. But it doesn't cover the question that, like, how do you actually deploy the models as microservices? And that's, of course, something that Seldon has been doing successfully for many years already. And like, hence, at some point, like, we started seeing this connection between Metaflow and Seldon, seeing that Metaflow is a good tool for building the models, Seldon is an excellent tool for deploying the models. And together, they can cover the full end-to-end life cycle of modern machine learning projects. And of course, like, what is especially appealing about the stack is that both the tools are open source, although both the tools are also backed by companies who can provide commercial support. So this is something that, like, can help you really put machine learning to production. So today, like, we have a number of presentations by different folks who are working on these projects. Like, we start with an introduction to Seldon, then we continue with the brief overview of Metaflow. And after that, like, we will see a live demo of how you can use both Metaflow and Seldon together to kind of go from all the way from prototyping to deployed models in production. And then after this, we have a special guest, like, from Netflix, talking about how Netflix uses model hosting patterns like this in production to kind of to serve their internal use cases. And then in the end, like, we will have an open Q&A. So during the presentations, maybe you can post questions to the chat, and then we can discuss those questions in the end. And of course, like, in the end, like, you can ask your questions as well. And pretty much, like, all the presenters here today are technical people, like, working on these open source projects. So I believe that no matter how technical your question is, or even non-technical, I mean, like, we are able to answer. So keep those questions in mind, and like, definitely, like, be active and, like, ask questions during the presentations on chat and afterwards. So I hope we will have an exciting day. And, like, I hope that by the end of this workshop, you have an idea how you can set up a stack like this at your company, at your environment, that allows you to go all the way from prototype to production. So with that, Clive, do you want to say something about Seldon, and then, like, go ahead, like, with the introductions?
Yeah, cheers. Thanks, Ville. So I'm CTO at Seldon. So I've been working in cloud native MLOps for many years. And I'm joined today by Alejandro Salcedo, our director of ML here at Seldon. So at Seldon, yeah, we provide a suite of products that help companies put their machine learning models into production. So really sort of specialize and center and focus on that last part of the sort of traditional ML pipeline. So we interface therefore well with Metaflow, and hopefully during today, you'll see how those two products fit in really well for the whole ML pipeline. So some of the things we'll be discussing, giving you an overview of what you need to concentrate on from the Seldon side in terms of really getting those models into production. Obviously, there's the core deployment onto scalable server farms like Kubernetes, scaling, updating, A/B testing, so progressive rollouts, but we'll also be diving into some of the things you may not be thinking about, like explanations, outlier detection, drift detection, adversarial detection, and so business logic orchestration. So some of the things you need to think about when you're really getting some things to really push it into production. And we'll show how you can really fit things together. We have a Python SDK we'll be introducing called Tempo that works well with the Seldon ecosystem and plays well with Metaflow, and there'll be a demo of that during today. And so we're really going to show you how that really works well with Metaflow and Seldon, get a great partnership for end-to-end ML. So yeah.
Great.
Back to you, Ville.
Yeah. Do you want to like, take over screen sharing and, like, show your slides about introduction to Seldon, or?
Sounds good. So yes, we're giving you an introduction to Seldon, a few slides on what we do, give you some background, and see how it all fits together. So obviously, any MLOps talk has to show a slide that begins with the Scully paper. I suppose that's very traditional, but the main thing to highlight here is there's a set of companies that are really coming together to be the sort of best of breed in different parts of that sort of technical debt that Scully was talking about. And Seldon, we're really trying to focus on the serving, the monitoring area of that technical debt. And obviously other companies, including Metaflow, that are trying to tackle some of the other parts. We're really seeing that a lot of companies are really choosing to create sort of best of breed solutions, picking the tools that fit their needs to create that sort of end-to-end machine learning pipeline. And really, especially also with this sort of cloud native focus, to have that sort of vendor neutral, some multi-cloud sort of final solution, which is obviously fits into what Seldon are trying to do in terms of having an open source solution, which is cloud native. So in terms of what we do and how we fit in, just to get me a bit more focus, obviously we want to fit in well with tools that come in earlier in the pipeline, that focusing on the data, feature engineering and training. So we want to tie in to any of those tools, be it Metaflow or MLflow or other tools that many of our customers use. And then we really want to if you want to see what we do, is sort of really these 3 areas that I suppose tie into sort of day 1, day 2, day 3 sort of things. First is obviously the core serving. You've got your model, trained it, and you want to put it out into production, scale it, update it, etc. And that's what Seldon Core is our sort of core product that we've been around for many years, that we've got thousands of customers using, and that's focusing on that area. But then after that, you realize obviously you need to monitor it, and we'll go into some of the aspects you need to monitor for your machine learning models, and we focus on that, both on our open source and closed source projects, to really give you an understanding of how my model is performing, when do I need to re-update my model with new data, retrain it, etc. Is there strange data coming in? So that's the next thing you're going to have to get right. And then obviously, especially in areas where you're more highly regulated or audited areas, you're going to want to explain your model. So, for the particular predictions going for your model, can I give a humanly understandable explanation for my model? And then you might need to tie in different techniques that depend on the type of data you're using for that model to get the appropriate explanation technique. And we really fit into those 3 areas. And we definitely see customers going through that journey of realizing, okay, I just need to get my model out there at scale and put it into production, maybe thousands of models, and what is the tool for that? Seldon fits that, and they start to realize, okay, once I've got that day 1, then I need to do further things. I realize as my whole stack starts to really sort of mature, and these further concerns start to come in terms of monitoring and explanation. And obviously, for this talk, so Metaflow fits in perfectly for that. So that's that earlier part of the pipeline. So in terms of the actual products that we have in Seldon, in terms of the open source, there's Seldon Core for actually deploying your machine learning models onto Kubernetes. And we also have a couple of other projects that we'll be discussing today. Seldon's Tempo project, which is a Python SDK, which obviously fits well with Metaflow in terms of being another Python SDK. And also Seldon ML Server, which is a Python-based machine learning server to allow you to run at inference time your Python-based models, and also your custom Python frameworks, which is important for some of the stuff we're going to be discussing later. Then we have a suite of libraries under the name Alibi that look into both monitoring and explanations. We've got Alibi Detect, looking at outlier detection, drift detection, average cell detection, looking at sort of state-of-the-art techniques in those areas. And then another library, Alibi Explain, for looking at ways to explain your models. Then we have obviously some commercial products that sit on top of that, but we're basically an open core company and bringing the commercial products above that. So in terms of just where we're going to get through today, obviously we'll allow Ville and Oleg to come to the final demo, but what we're going to try to show you is like training your model on Metaflow, and then deploying it out onto Seldon, and allow you to do that so you can train locally, test it locally, make sure that's great, while you're sort of developing your model, testing it out, and you can test out with some production artifacts, test it locally on Docker. And then when you're ready, go to the next stage, when you want to scale up, train at scale, and then get things ready for production, put it at scale onto Kubernetes. You can then do that very simply, some minor changes with the same pipeline. Then it's ready to go using Seldon Tempo as the Python SDK and Seldon Core to actually run it at scale, actually on your Kubernetes cluster. So now I'm just going to take a step back and sort of look at some of the sort of challenges that made us think of what we want to do for creating a Python SDK that works well for data scientists. There's several things to look at. One is, you've also probably seen this sort of diagram before, that sort of the data scientists with their skills on the right, and like Python, and they've got particular toolkits, TensorFlow, etc., that they're very skilled in. But when they want to push it to production, there's a set of tools, especially in the cloud native world that we work in a lot, and a lot of companies are actually trying to adopt, is the whole separate set of tools that they're not actually very familiar with. And so you've got this real gap. It's quite a classic gap that makes it very hard then to push the models that the data scientists are creating into that production like arena, because there's a whole different set of tools they're not very familiar with. And so the challenge is, how do you make it easier for the data scientists to actually push out to production in a much simpler way without having to learn some of these tools? Because if you're saying you're going to push out to Kubernetes, then, well, do you actually, as a data scientist, need to learn all those different skills of Kubernetes? You need to become familiar with the YAML and kubectl and the different types of custom resources and resources that exist in Kubernetes, such as deployment services, etc., and ways to scale it. You probably, as a data scientist, maybe eventually to optimize some of it, you want to be exposed to that, but you probably have DevOps teams that can work more closely with this. And to get it to production, it'd be nice if you didn't have to learn all of these different aspects. So with Seldon, obviously with Seldon Core, it's very much a Kubernetes-focused solution. So we're trying to see with a Python SDK if we can abstract some of that complexity away. So as a data scientist, you can just work in the domain that you're more familiar with, just creating the appropriate artifacts in Python and then pushing it out to production without having to understand some of the complexities that lie in terms of Kubernetes, the actual Kubernetes world that you're going to. So another thing that we see is that people, obviously, when they're taking their first steps, that they think, okay, I just need to create the model. That's my core role as a data scientist. But generally, as you start to mature in your actual putting machine learning models into production, you realize there's a lot of extra components you're probably going to need to really have a mature solution, such as explainers, as I said, outlier detectors, drift detectors, maybe adding feature transformation components, because you're not going to have sort of tensors come in maybe from your actual business logic that's actually calling the models. You maybe need to do some feature transformations before you get to the actual optimized model server. Maybe you need to do some feature transformations after the model server to send it back in the appropriate way to the actual business that's calling it in a certain way. And then obviously more complex things, which maybe are more niche. We only see a small set of customers, but we do see customers using it, things like multi-armed bandits, when you want to actually have many models that you want to test, and maybe you want to actually try to optimize between them in real time. We certainly have customers using that, where they have different types of traffic that change over the day, and they have different models they want to switch the traffic to in real time. And then obviously allowing you to run multiple models, so actually creating so ensembles to take the result from multiple models and then combine it together. And then obviously, finally, you want to think of how you're going to actually version control all of this. So obviously, a lot of our customers use GitOps. We won't go into too much detail today about that. Having everything in version control, so you got a whole audited set of commits for every piece of infrastructure you've updated, and you can then roll back to any one of those stages. So you've got all these different artifacts being created, and you've got maybe the Kubernetes YAML that's the final output, and you've got a nice audit history there. And that's obviously the way our customers, a large number of our customers, use the sort of GitOps paradigm with the output of some of the tools you'll see today. And happy to go into more detail about that as we go into questions further down the line. So there's also another thing that's also interesting that comes up in terms of what we've found in terms of creating the Python SDK, is that also really the model just doesn't sort of sit on its own. It's just the inference server. Normally there's going to be some sort of business logic that's quite particular to how the model is called. And you might want to put that closer to the model in terms of creating that for the final solution. So if they're quite separated, it makes it harder to version control and make sure they're both aligned. So you might be calling different models and maybe doing some very particular things which are particular to your way that you're using the model to actually solve the particular sort of business problem that you're trying to solve in your company. And you might want to add that logic near to the model to get that whole solution. So if they're quite separated out, again, it makes it challenging to make these different versions of your model and the actual business logic when you make updates to keep them in sync. And so again, it'd be nice in the Python SDK if you could add that sort of custom business logic in what you're doing. So we're trying to create a solution for that, so you can use that very easily in Seldon to get the whole solution that you want to actually push out. So now I'm going to introduce the Python SDK that we've created called Tempo, which works well with the Seldon ecosystem to allow you to do all these things. And we're sort of going over those previous sort of challenges that I've just discussed in the previous slides. There's sort of four things it's sort of trying to sort of solve. One is to be sort of data science friendly, because we realized that Seldon Core, which obviously we had a lot of success with Seldon Core in terms of thousands of companies using it, but it is quite a Kubernetes sort of specific solution. So it's using YAML, you use kubectl to actually create the deployments, etc. So can we sort of abstract that away, so data scientists who find that slightly challenging to use, they could just use the Python SDK and just work inside that without having to learn some of that. So it's some of those earlier challenges I talked about. Then also to get around the sort of things like creating more complex suites of components, and not just the pure model, but the other aspects like explainers, outlier detectors. We wanted to create it easy so you could combine different components in the Python SDK and allow and tie them together in a really easy or sort of functional way, so you can build up more complex components. Then also we want to make it easy then when you deploy, you can test it locally. So, it's great when you're just creating the first versions of your actual model to test it locally on Docker, but actually test it with the actual production containers that will eventually be run in Seldon Core, eventually at scale on Kubernetes. So you really get an understanding that it's actually going to be working because you're using the same containers, the same infra service that will be running in Seldon eventually, and you can just test it locally, so there's no surprises when you actually push it out. And eventually, with no changes, you can just say, okay, so deploy this remotely, and it will deploy it out onto Kubernetes cluster. So making that really easy to do. And making that transition also quite easy to do. So if you want to be a data science that just tests it locally, and then you pass it on, maybe pass the YAML on, you can output that all from the Tempo SDK and then pass it onto your DevOps or put it into your GitOps system and run it that way. Or you can actually deploy directly from the Tempo SDK directly onto a Kubernetes cluster running Seldon Core. And we'll show that later in the actual workshop. And then finally, yeah, that sort of custom inference logic. So not just allowing you to just focus on the actual artifact you've created, but also allowing you to write arbitrary Python to bring in any libraries. Obviously, that ties a bit with the bit on the left, where you can bring in maybe other libraries like Alibi Explain from Seldon if you want to do explainers, but really allowing you to bring in any libraries, packaging that up, and then so making it really easy to put custom Python code there. It's sort of some of the sort of things we're trying to solve with Tempo to make it work well with the Seldon ecosystem, allow our customers to use our Seldon products much more easily. So now I'm just going to go through a few sections on how Tempo looks. So it provides a very simple set of abstractions, some decorators and objects to allow you to create your core models and your custom Python extensions. So here you see a simple model object. And it just has a few very simple things that you as a data scientist need to add. So you give it a name. So in this case, maybe a scikit-learn model you've trained inside Metaflow. So give it a name. This is my test iris sklearn model. So what platform it is in the future, we're going to try and see if we can optimize this so we could just work out that this is a scikit-learn model. At the moment, you say, okay, this is actually a scikit-learn model. You say there, you say where it actually is located on the local folder, where it's going to be eventually for the production runtime, so we can upload it also for you automatically and give it a description. There's some various things inside Tempo that allow you to say which models are running if you've got a connection to a live cluster. So it's very simple to allow you to create the simple artifacts from your core models that you've trained in a simple way and get them ready to actually run for the next step. And then obviously take it to the next stage, we can build up more complex sort of graphs basically. So you can maybe envision having a couple of models that you've created, one sklearn model, one XGBoost model, and then you've got a bit of sort of custom Python logic you've got there. So maybe here is just an example. Maybe we call the sklearn model, we'll show you an example in a second, but you can call it pretty much like a function. And then you can get the result back, check maybe something and do some logic. So here it's very simple, just implying that you might want to make some decision and call one model up rather than the other. And this is sort of focusing on doing that sort of custom business logic. Maybe you have some headers or other things you want to do to make a decision on what you want to do for this model that's particular to your use case. We want to allow it to make it really easy to add that custom logic. So this is how you take it to that next stage. There's another component called a pipeline, which allows you to add that sort of custom Python code with using any libraries that you want to add in. And you basically has two parts. So when you can say the models, the core so building blocks you want to call. So obviously before we showed you there was an sklearn model and XGBoost model, and you can say which models you're going to be calling out from your custom logic. And then you could just add in any function to actually call out to those models and add in any other custom Python code that you want. And we'll handle all the complexities of turning that into the lower level protocols and sending that to the actual inference server. So you can just do your standard Python typing, say, yeah, okay, I'm expecting like a ND array, a NumPy ND array, and I'm going to return a tuple of an ND array and a string, and it'll turn it into the low level V2 so payloads that we support inside Tempo and ML server, which I'll talk about in a bit. That's all handled for you, so you can just work at this level of the pure sort of Python level to create up that complex structure for what you want to run. This is how it all ties together. So you can imagine, you train your sklearn model using some standard sklearn. Maybe you train your XGBoost model. You've got those ready. You create the tempo artifacts, and you bring it all together in an orchestration component. So here's the sort of full tempo artifact Python code for that example we showed on the previous slide. You've got two models here. So a sklearn model, XGBoost model, pretty much just as I showed you a couple of slides ago. And then you've got a pipeline that sort of references those two and then does some custom logic just to illustrate how you can tie things together. So when we actually push it out into production, these are the standard servers that we actually use inside Seldon Core for different types of models. If you've got a TensorFlow, PyTorch, or Onyx model, we're putting out onto the NVIDIA Triton inference server. And if it's a Python-based model, XGBoost, sklearn, or that custom Python that I showed you before, we'll be putting it onto Seldon's ML server and running it for you. And so this will also be used locally if you want to test locally on Docker. So just going, you may have heard of the NVIDIA Triton server, but in terms of Seldon's ML server, it's basically a Python-based model. It allows you to run, it has different run times to focus on various serving artifact types. So it's got XGBoost runtime, sklearn runtime, and it's also got one for tempo that allows you to run that sort of custom Python code. So it'll package it all up into a Conda environment. It'll unpackage it, that whole environment, and have it running for you. So this is how we allow you to actually run that sort of custom Python code and make it very easy to add that sort of custom business logic. And so in terms of how you would then bring it all together, and you'll see this in the demo later, so you could then, these are the steps you'd go through. So you have your local development where you're testing out your model, you're creating it, trying out different things, you're creating artifacts in local folders, and then you can test it out locally, and that will all just run on Docker. And then when you're ready to go, you can push it to the remote object stores you've got, and then that'll run remotely on ML server, running on Kubernetes. And so we manage it to make, we've got very simple functions, so we can make it really easy for you. So we're using things like rclone to push out to any of the object stores you might use. If you haven't heard of rclone, it's a great tool that handles about 35 or 40 different remote object stores, so we can interface into any stores where you might actually push out into production. So it makes it really easy to go through these different steps and run your pipelines when you're ready to. So just a few things then in terms of the last steps here that I want to go over is some of the things that are the more complex things you might think on sort of day two of when you're putting things into production. So explanations, we have a library called Alibi Explain that allows you to have different types of explainer algorithms that can be used for different types of data, input data. So you can see here on the left, I won't go into detail all the different types, but there's a large range. And some of the challenges, some types of explainer algorithms are good for different types of stakeholders, and also for different types of input data and how the model has been trained, where you have access to the training data, etc. So you've got some examples here on the right. So you've got ones that's very focused on images. This is anchor explanations for images, where you're saying, okay, why was this a Siamese cat? It'll find the particular part of the image that the model was using to make it predict Siamese cat. Obviously, you need a different technique for text, where you're saying, okay, why was this like a positive sentiment from the classifier, and it'll highlight different types of different words within that input text that the model was looking at to actually say this is classified in a certain way. But you also got to take into account when you think about explanation algorithms, who's actually going to be trying to use them. So you might want to use things like counterfactuals, which are very good for people who are sort of non-technical. So it gives a nice way of saying, how could I get from one result of the model to a different one? This, you could imagine this to be things like sort of loan classification, where you say your loan has been denied by a machine learning system, and you say, okay, can you give me an explanation of how I can change the model to make it actually accept the loan? So in this case, you've got an example of a slightly more simple case of just like images of, so MNIST basically, so you're saying, how would I change this 6 in the first example here and get the model to classify as a 5? And it sort of shows you can just rub out a little part of the image. So I think, I don't want to go into too much detail, but it's just showing that there's quite a whole sub area of explanations that you need to look into, of how you can use explanations to best understand how your model is actually creating predictions. And we've got libraries like Alibi Explain, which can be used in Tempo. So you can bring these libraries in to get the appropriate explanation algorithm to use in Tempo. This is an example. We have an example in the docs of Tempo to show you how you can utilize Alibi explain to actually add and explain a component, which maybe then calls out to your actual model you've created earlier, say in Metaflow. Also, the other thing you need to think about are things like outliers, drift, and maybe more niche adversarial detection. Again, we've got a library open source for that one called Alibi Detect. Again, allows you to provide a whole different range. So depending on the input data, things like outlier detection, whether it's tabular, image, time series, and we've got a whole series of outlier detection algorithms that work for different types of input data. And the same goes for the other two areas of adversarial detection and drift detection. So again, you can add those in really simply to the Python SDK and Tempo and use them as needed to get that sort of full, sort of rich system that you want to eventually get to as someone tried to put machine learning into production. Again, yeah, there's an example here in Tempo. You can, we'll hopefully get the slides after the workshop where you can show how, in this case, you can add an outlier detector. So you can add your custom logic, so it's going to call the outlier detector first. If it thinks it's an outlier, this is created from so Alibi Detect, then you can just return it straight away because you don't want to call the model if you think it's an outlier, because you're probably going to get like a result that can't be trusted if the model is being trying to create a prediction part of the actual input space it hasn't been trained on. So you can use outlier detection as part of the sort of synchronous request response flow to really make sure that you don't get results back, which will go back to your business logic when you think it's an outlier. So it's a great thing to add into your some more mature some machine learning so inference pipelines. And we've got an example in Tempo that allows you to do that. So yeah, really just finishing off now. So what we're trying to get to is obviously bring these two things together, Metaflow and Seldon, to have the parts that they really specialize on, Seldon for those things I've just talked about, and Metaflow that we discussed in the next section, allowing you to then build up, train your models on Metaflow and push them out very easily with Tempo, both being sort of Python SDKs, test them locally, and then test them onto Kubernetes. So I think that's my final slide for the introduction to Seldon. So I think I'm going to hand back to Ville now, if I can.
So thanks, Clive. As Clive showed there in one of the last slides, like how we think about Metaflow and Seldon working together is that Metaflow is kind of the part that covers the very beginning of your project, and then as you kind of get nearer and nearer to the production and you want to kind of make the products more and more mature, then Seldon provides all those tools for deployments and explainability and monitoring and so forth. But I wanted to start this presentation by giving you a very high-level overview of why we started Metaflow in the first place at Netflix many years ago, and what was the problem space we were looking at. So actually, I just wanted to start the presentation by mentioning that Metaflow is, of course, an open source project. We have a community Slack at slack.outerbounds.co, which is a company we founded recently to help all companies who are using Metaflow and to advance the open source community. So if you have any questions after this workshop about Metaflow, you can definitely join the Slack and we can help you there. Also, of course, help you to point at the right people on the other Seldon side as well. And I know that Seldon, of course, has their own forums as well. But I wanted to start by giving that high-level motivation. And what Clive was just talking about Seldon, it touches the questions that once you have these models and once you operate the models in production, then you really have to kind of think in detail that how you make these systems robust and how you make the systems understandable and so forth. But of course, even before you get there, you have to answer the question that where do these models come in the first place? And as many of you know, Netflix has been using machine learning for a long time, for more than 10 years. And of course, the most well-known machine learning application at Netflix are the personalized movie recommendations that you see when you log into netflix.com. And this was the situation when we started building Metaflow many years ago, that there was the recommendation system. But what happened over time is that we started getting an increasingly diverse set of different use cases in addition to this one recommendation use case. As the company was going global, of course, with that came a lot of new kinds of problems. And as the company started producing its own movies and TV shows, with that, there came up many opportunities for machine learning. And there was the question that how do we serve all these data scientists who try to build these data science applications, models for different use cases in the most efficient manner? And like the use cases that like we were looking at, and I'm sure that Roman, like who works at Netflix, and like we'll talk more about like the overall landscape. But I mean things like natural language processing and things like predicting churn. I mean like a very kind of mundane business problems that don't necessarily require even deep neural network models. But I mean you can use logistic regression. But I mean still kind of the problems are similar. Or like maybe you want to do things that are technically not even machine learning, like kind of when you look at the models. I mean, you can use things like operations research to optimize production schedules, or like, of course, like then you can use really bleeding edge DNN models for computer vision. But what you can see is that there are many different types of machine learning problems that oftentimes pop up in a large organization. Or of course, like even if you are not a large organization, it might be that like only one of these use cases applies to you. And then you may wonder that like, should I use one framework or another? And like, what is really common about that all these use cases? So that was the big question that we started asking ourselves, that on the one hand, all these, well, I mean, I guess they're technically not even all machine learning, but I mean, at least they seem to fall under that umbrella of data science and machine learning overall. But the models are very different. And it kind of feels that like some concerns are, let's say, like a very specific deep learning, and like some concerns are more specific to, let's say, like classical statistics or classical machine learning. But it feels also that there are some concerns that are common across all projects. And of course, like one like really obvious answer, if you look at all data science projects, is that like, well, all projects need data. The type of data, the modality of data may be different. So it may be structured data, like maybe tables for churn prediction, like maybe you get something from your database, or it might be unstructured text or images, or like maybe it is just like a time series, maybe some kind of a metric. So data of different types, but it's data nonetheless. Another thing that like we realized is that all these applications, regardless of the model, the type of model they use, they need to perform compute. And I think that this is a bit of a underappreciated aspect of all data science and machine learning projects, that somehow you need to be able to compute these models. And like, we are not only talking about training the model once in a notebook, but oftentimes you may want to have multiple different versions of the model. So you want to maybe like run different variations of the model, and maybe you want to do it in parallel, or maybe you do hyperparameter search, and like you need to actually have quite an amount of compute power. And of course, now you have many people doing it at the same time. So there's a question that like, okay, so how do we manage this compute? Another realization is that like when we are talking about compute, we are not talking about only a single function that needs to be computed. I mean, it might be that you have your model fitting function, maybe you run your convex optimizer or something, and that's one thing. But practically speaking, all these real life applications consist of multiple steps. So maybe you have a data pre-processing step, maybe you fetch the data from a database, maybe then you like create the tensors, and then like maybe you train your model after that. Or maybe in some cases you run different variations of the model, and then maybe you choose the best one and like write the results to a database, or all kinds of things. And it really depends on the application. So of course, it is not surprising that oftentimes these days people structure machine learning applications as a workflow, as a DAG, as a directed basically graph of some kind. So this DAG abstraction seemed very central to machine learning projects as you are building these applications. And then if you have more than one people working on these projects, what typically ends up happening as well is that, okay, now you have a workflow, and you have one person, you have Alice, like who created one version of the workflow, and maybe Bob joins the project and like wants to hack something in the Alice's version. So now you have another version of the same thing. So you kind of need to be able to run multiple different variants of the workflow, maybe even at the same time. So you can do A/B testing or something of that sorts. So your systems need to be able to support not only a single version, but multiple parallel versions, like running on the workflow scheduler. And then another thing that is like pretty much given like for all data science projects these days is that nobody is writing the whole stack from scratch, but you leverage off-the-shelf libraries like TensorFlow or scikit-learn or stats models, so PyTorch. And like crazily enough, a single project can actually leverage multiple different machine learning libraries. So maybe you have both scikit-learn and TensorFlow side by side for different purposes. Maybe you use something like PyTorch to produce embeddings that you feed into a different model and so forth. So you kind of get this like a whole hairball of different dependencies that you have to manage somehow. So I mean, this is actually another kind of a really underappreciated problem in many data science projects these days. So then the kind of a question we asked ourselves is that, okay, as we recognize that we need data, we need compute, we need workflow, we need versioning, we need dependencies, instead of asking the data scientists to handle all these concerns using kind of a point solutions, could we produce a single coherent framework to kind of handle all these basic concerns, like using a single API, using a single user experience? And that was basically the motivation, like what we started building Metaflow in the first place. And like we were thinking this as in terms of this stack. And this is very much now focusing on that like early part of model development, kind of a complementing what Clive was saying about the kind of a more like a mature, like the deployment and the operations part of model development is that, okay, so we need to know how we access data, and we need to know how to access compute, workflows, versioning, and so forth. But then like, as you go like towards the top of the stack, you also have this like a very practical questions that, okay, how should I architect my application in the first place? I mean, like, how do I even like write the Python code? And like many of you as data scientists, you are maybe comfortable writing code in a notebook, but I mean, as the complexity of the application increases, kind of how do you architect as a workflow? And let's say I have to update my model every day. So how do I make that happen? Maybe my model today needs to access the model from yesterday. They're like all kinds of practical concerns. And I guess indeed, I mean, there's that like a chart that Clive showed about the hidden technical depth, and that's the architecture part is really where that hidden technical depth seeps in. Like you have that infamous glue code that is kind of all the stuff that you feel that, oh, it's all the additional stuff in addition to the model, but in a way, I mean, that is really the core of the application. And then on top of that, like you have this like a more modeling specific concerns that, okay, how do I know that my model is actually working? Kind of go into that explainability topic, or like, how do I engineer features for my models? And then finally, like, what is the model architecture? And the philosophy we had as we started thinking about the stack is that oftentimes we saw that the data scientists are, of course, domain experts, and they very much care about things here at the top of the stack. Like they know like what kind of a model architecture like roughly makes sense, and like kind of even when it comes to fine-tuning the model architecture, that's where they really want to spend their time and expertise. And the same thing, understanding the data, becoming a domain expert in the data, doing the feature engineering, something that they should really do well. And also like model operations is something that like, well, at least like as a data scientist, you should have an idea how you can measure the quality of the model, the accuracy of the model better than anyone else. It's kind of hard to do that fully automatically. And also like kind of the architecture is something that it's kind of like starts to overlap with the software engineering questions, but at least you know like kind of what the application should be doing. But then like as you go like downwards on the stack, as you think about these very mundane questions that, okay, so how do I access terabytes of data from my data warehouse, or how do I run compute at scale? Many data scientists were happy if these problems were just kind of handled more or less automatically. Like at the end of the day, if the question is that, okay, how do I run my Python function, or how do I run my Docker container, whether it runs on Kubernetes or AWS batch, I mean, like the result is exactly the same, and it doesn't really make much difference as long as it complies with your company's like security setup and like kind of data governance policies and so forth. So the idea was that, okay, so with the infrastructure like Metaflow, we can especially focus on the lower layers of the stack, and then like at the top of the stack, like we can give more freedom to the data scientist. And now another big realization as we worked on many different projects at Netflix, and now like with many other companies outside Netflix as well, is that, of course, we realized that the path to production is really incremental and iterative. It's not like one day you are like just prototyping something and the next day like you are fully in production, but it's really a gradual process. And like we started thinking that, okay, so what are all these like little milestones on the way as you approach production? And in actually like kind of, I should add here on the timeline that, of course, like even thinking about that like maturity curve that Clive shared earlier as well. I mean, there is actually like a steps even further on this timeline, like thinking about questions like monitoring and explainability and so forth. But even like before we get there, like early on, I mean, you have these questions that, okay, do I develop my models on my notebook? Should I use some cloud-based workstation? What exactly should I do in notebook? Should I write all the code in notebooks, or should I only do maybe some kind of explorations analysis in the notebook? And then if not notebook, I mean, how do I actually like create the workflow? Is it going to be a YAML file? Is it going to be a Python file? What exactly is it going to be? And like, as I write the code, how do I version? I mean, I can certainly use Git for versioning the code, but I mean, like, where do I version my models, and like where maybe even like where do I version my data? And there are of course tools like very specifically answering these questions. But the question is that, okay, so is that the kind of the right thing like for your company? And then the questions after that is that, okay, so let's say you have maybe either a workstation or a notebook and or a laptop like running a notebook. And then like you have a big pandas data frame and like it doesn't fit in like a 16 gigabytes of RAM that you have available. What do you do then? And of course, like one classical answer is that, well, I mean, maybe you should be using Spark. But if the feeling is that like, well, I mean, the data frame only takes, let's say 20 gigabytes. So it's just like a few gigabytes more. So it kind of feels silly to re-architect the whole code and the application. I mean, just for the few additional gigabytes. So maybe it would be convenient if you can scale it out to the cloud. Or maybe it is so that like you now want to run multiple models in parallel. So instead of buying 100 laptops like running in parallel, it is certainly convenient that you can farm out the compute to the cloud. But again, I mean, you want to do that kind of as easily as possible. And now when you have all those things running in the cloud, okay, let's say you have 100 servers, like each with 20 gigabytes of RAM, 16 CPU cores. And now if they all hammer your data warehouse simultaneously, I mean, this is basically a distributed denial of service attack against your data warehouse. So maybe that is not the best pattern for accessing the data. So you kind of need to think about the data access. And after you have figured out that part, well, I mean, you definitely don't want to run a production pipeline by hand every time, like every night that the model needs to be retrained. I mean, you are not supposed to go on the console and click run or something, but somehow it's supposed to run automatically. So there's the question that, okay, how do I schedule the whole workflow? And then like, of course, with that comes the question that, okay, so what if the scheduler goes down? Do you have a robust enough infrastructure for running these workflows, and like what that should look like? And then a fun detail that like happened a couple of times early on, like even for us, and like back in the day at Netflix, is that, okay, so now your project depends on some upstream packages, and these packages change rather quickly in the world of machine learning. And one night, one package changed, and like kind of somebody baked their Docker image, maybe kind of without pinning all the dependencies, and this like broke the whole pipeline. So you want to avoid situations like that. And of course, like maybe some of you know as software engineers that there are best practices how you are supposed to pin the dependencies and so forth. But especially like if this involves like writing Docker files and so forth, I mean, it is actually like a lot of extra work for data scientists. So we also wanted to think that how can we do those things more easily? And then like as you kind of get closer to the deployment stage, well, it's not only a single deployment, but it's potentially multiple deployments, as we discussed before. So the question is that, okay, so how do I run these parallel pipelines so I can have a production version and an experimental version and then like do A/B testing? And that's something that like you kind of need to, all these parts need to be able to comply like with these like isolated paths. And then like, let's say you finally manage to deploy something, or maybe you have a model being retrained nightly. Then a question is that, okay, what if something fails? And now a big question, and this is of course a big problem if you have, let's say, some kind of a handover that you have a data scientist, maybe modeling scientist writing the models, and at some point you hand over to a software engineer or ML engineer. And now let's say the kind of a whole thing, the training fails in production. So now is it going to be the ML engineer or the data scientist actually analyzing what's going on? And the model we adopted is that like it would be optimal if it could be a single person, like with the help of infrastructure taking care of these things. And even so that when something fails to production, you can reproduce those issues locally and understand what's going on. So this is kind of the problem space that like we wanted to address with Metaflow. So I think that the key thing and like a key takeaway about this picture is that there are really many individual kind of milestones and problems you need to address in these projects. And of course, this is not even all. And like only, let's say, focusing on versioning or only focusing on scaling or only focusing on workflow isn't not going to do it, because you kind of need to answer all these questions. And the challenge is really amplified by the fact that there isn't even a single, I mean, that was a linear kind of a path, like showing that, okay, then like in the end, there's a one way how everybody deploys, but there isn't a one way how everybody deploys. In some cases, oftentimes, let's say, we can create predictions that are pre-computed, and like instead of doing anything online, we just like store the pre-computed results in some kind of a cache. Or like maybe in many cases we had some internal applications that were basically decision support systems, and like the predictions went to a database where then some Tableau dashboard or like some other custom dashboard accessed the results, but there was no kind of a model serving by itself. involved. But then in other cases, maybe we wanted to have machine learning models that helped other services to do something smart. So we wanted to deploy these models as microservices. Or like maybe like we had a prototype UI that needed to access these predictions through like a simple HTTP RESTful API. Or like, of course, like in the extreme cases, like we have cases like let's say the recommendations at Netflix, like where we really need these real-time predictions and they need to be highly scalable, highly available, all that stuff. And that's a kind of a big question of its own. And like the way, like how we think about it, and like when we started working with the Seldon folks, is that we saw that there are like all these big problems that like Seldon has been thinking about for a long time, and they have a system that helps you to deploy models as microservices and like expose gRPC and HTTP APIs and whatnot, and provide all those model monitoring tools and like scalability tools that allow you to run really production grade infrastructure for model serving. So that's kind of the focus of the workshop today as well. And I don't want to spend too much time like on just like talking about what Metaflow is and like what it does in detail. I mean, there's a documentation available online. We can also follow up later on Slack. But I mean, just to give you a quick teaser, if you haven't ever used Metaflow before. So the basic idea is that you can just use like a very simple Python code, basically like code that you could be writing in a notebook to define a workflow. And here in this case, you can see that there's a one-to-one correspondence between the steps and the nodes on the graph. So here's a start step, here's a start method, here's an end step and like an end node here in the graph. And then there's the self.next, which defines the edge or the transition between the start and end. So simple enough. So this gives you a workflow. And then like what Metaflow does for you is that it just adds a very simple CLI interface on top of the workflow. So now you can run the code locally, and Metaflow comes with a built-in kind of a small workflow orchestrator, so you can test code locally. And this is something that we felt is really, really important, that not only the production side of things needs to be smooth, but also the prototyping side. And this is, of course, a big reason why notebooks are so popular in data science, that they make the local prototyping experience really pleasant. And we wanted to continue the same tradition with Metaflow. And then since I mentioned about those like scalability questions, then the next idea was that, okay, given that we have these amazing compute resources available in the cloud, and these are available for anybody's disposal, like on AWS, is that like we can make it very easy for data scientists. Just basically say that, okay, if I have the data frame that needs 20 gigs, 100 gigs, maybe even like a 300 gigabytes of RAM, you can just say that, okay, here's a function that it needs this much memory. And then the framework can take care of, let's say, running this code here, like with batch, which means that like we can use AWS batch, which is a simple kind of a managed compute backend, just basically provisioning EC2 instances for you and running the containers there. And what Metaflow does in this case is that it takes your Python code, it even can take the dependencies you have defined, and it sends them like to the cloud. It sends like kind of the packages of everything, writes to S3, and then like it starts a container like using AWS batch, and then executes the piece of code there. And the big thing that Metaflow does is that it also persists the data, so that like whenever like you produce something here, like those artifacts become available in subsequent steps. So you don't have to kind of have a boilerplate for storing and retrieving data like at every step separately. And then like when it comes to the question that, okay, how do we do a parallel compute? How do we do many things at the same time? Well, Metaflow makes it pretty easy that you can specify any Python list. Then you say that, okay, I want to do a for each, kind of like a map function over this list. And then again, like when you do something like a run with batch, and I specify these resources, now Metaflow takes care of running, let's say in this case, even up to 100 parallel instances, each with this amount of memory, and like you can train, let's say 100 models in parallel. So this by itself is quite powerful. And now you have this join step where you can, let's say, choose the kind of the argmax or like the best performing model. And now Metaflow includes many other features that like help with all those milestones that we saw on that scale, on that path to production. So I mentioned dependencies, I mentioned state management, also like interaction with notebooks is an important one. And then definitely, if you are interested in learning about details, go to the documentation. We have some tutorials there, or come to the Slack to chat more. But the specific topic of this workshop, and by the way, this is like kind of, I mean, the fact that like we store all the snapshots of all executions as well. So this kind of addresses that question of versioning and on also experiment tracking. So you can analyze everything that happened in your workflows in a notebook. And then if you have a more complex workflows that even consist of multiple parts, this is kind of the A/B testing case where you have a training flow, you have a prediction flow, you may have different branches, A and B. You can kind of like manage that with Metaflow as well. So the idea is that as your projects become more complex over time, then the framework can grow with you, but it doesn't impose all that complexity on you like in the beginning. But really the topic of this workshop and what I wanted to focus on is that now let's say like we use all these tools that are available on the Metaflow side. And like, let's say you have these training steps and like eventually like you get the model. Then there's the question that, okay, now I have this model and like my customers expect to get the predictions over HTTP. How do we do that? Like, how do we do model serving and how do we do model monitoring? And now this is again, I mean, kind of a connecting kind of the Metaflow part to the Seldon part and showing that like these two tools are extremely complementary in a sense that like Metaflow takes care of that like early part of the process in a sense that you can prototype, you can like deploy these scheduled workflows, you can get your models retrained every night. But then like when it comes to the question that, okay, so how do we actually expose these models as some kind of a microservice or like web endpoint or so forth? I mean, now you can kind of rely on Seldon on cases like this. And after the next demo that Oleg will be showing, then Roman from Netflix will shed more light into these model deployment patterns that like kind of bridge the gap between Metaflow and then like a system like Seldon. So Netflix internally like has built an internal because they have a really pretty kind of a mature microservice infrastructure there that like kind of they use a slightly different path, but the patterns are exactly the same. So it will be very interesting to hear from Roman after the demo, like how that works on the kind of really at the kind of a large scale. But next, I can hand it over to Roman, like who can, I can hand it over to Oleg, who can show a demo how this actually works. So we have been working with Seldon guys now for many months to actually kind of bridge the gap and actually like also technically and not only like kind of at the level of slides. So let me see how I can actually make you a host so you can actually present Oleg. So, okay, Oleg,
host. Awesome. So I'll basically just show you a little demo, putting all those things that Clive and Ville talked about together into an example that is a little closer to production. And let me share my screen. So here's the example I'm talking about. So it's basically a classical data science toy problem with predicting something about flowers on the iris dataset. And in this example, what I want to do is to use Metaflow to schedule all the batch jobs on the batch compute. And that includes reading the data, training two models using XGBoost and sklearn, then producing some artifacts as a trained model with coefficients, storing that, and then using Seldon to deploy those models into production, into a Kubernetes cluster. And it's not just kind of deploying them independently. Actually, Seldon allows you to build those kind of real-time pipelines where we can call one or the other model and have a little bit of business logic where you have not just models running independently, but also additional logic to choose one model or another, maybe call the first one and then the second. Basically what Clive showed you briefly in his slides.
So Oleg, by the way, can you increase the font size?
Yes, I can.
Thank you.
Is that better?
Yep, it's better. Thank you. Oh, yeah.
Okay. So briefly, I'm not going to read through all the code, but when you work with Metaflow, like I just showed you, you're working with just normal Python code. I have a class here that contains all the steps necessary that I just described. The only different thing is that in Metaflow, you have to inherit from a special base class. So Metaflow is aware that this is not just any Python class, it's actually the class describing your workflow. And we have just a couple steps here. One to download the data set. So every method here is a Metaflow step, which will run in a separate container when deployed to production. So in the case of Kubernetes, it will be a pod. Maybe if you deploy something else, we also support native AWS integration. It will be some other objects in some compute environment, but essentially think about every step as a container running independently. And So the first step is to download data. Then it forks into two steps to train two models, one on using sklearn, another training against XGBoost. Again, nothing from data science perspective, nothing super interesting here, just run fit from sklearn or XGBoost. Then those model artifacts are actually stored in S3, and then at the end we use tempo. Where is my tempo step? This is the tempo step that uses tempo as a dependency and deploys those, creates two services kind of running Kubernetes cluster that at real time take the inputs and serve predictions. And this whole thing will run equivalently on locally with Docker, or in this case using the remote Kubernetes cluster in production. And let me just launch this thing, like Ville said. Let's this a little bit and increase the font, I guess. So we'll just run this Python code with a couple of parameters. One tells Metaflow that we're using Conda to manage all the Python dependencies for each step, and then we use a Docker image that includes Seldon as a already included in the Docker image. So the run hopefully will connect to my Kubernetes cluster remote that is actually running on AWS right now, and it will start running my steps one by one. I can switch now to my Kubernetes cluster. I use this tool called K9s to kind of look inside what's going on into my Kubernetes cluster. You may be using something else, but what you can see here is that while it's running, Metaflow created a container or a pod in Kubernetes that you can see from the name probably. So let me make it a little bigger. That right now it's running my start step, this one. And things it has to do to run it is, first of all, it actually has to provision all the dependencies for this step, which includes scikit-learn packaged in a Conda environment, and then download the data and then go to the next step. So usually, in this case, you can see kind of as usual, there's a lot of frameworks out there that can run your code in sequence and run it in some environment. But I think where Metaflow really shines is that all this dependency management is done by you in a very user-friendly way. So it will take care of packaging all your dependencies and uploading them to S3, and then while it runs this step, we'll download them, so it's all perfectly reproducible. It actually doesn't do any dependency resolution at runtime in this scenario. So if I go back to my Kubernetes cluster, you can see now that step is done. It's completed the first one. And then there are two next steps are running that train sklearn and XGBoost model. Looks like XGBoost took a little longer, but they're still there. I can also, if I stayed in my console window when I did Metaflow run, I would see all the logs. And there's a lot of stuff going on here, but you can see at least where it's provisioning the Python environment and then running your code. In this case, it doesn't take that long. And then I think in this case, it's the next step in my Metaflow run, which is the join step, and so on. So in the end, I hope we'll deploy a couple containers, again, in the same Kubernetes cluster to serve those models at runtime. I actually drew a little picture to illustrate what I'm hoping to see in the end is roughly this. And you can configure it in a different way. The way I configured it with Kubernetes right now is that Metaflow stuff runs in a separate Kubernetes namespace from production serving, which is probably good practice in production as well, because you may kind of set up permissions differently for those two namespaces or provision resources differently, so they don't, step on each other in any way. But all my Metaflow steps, all those methods that I just shown you, decorated with at step decorator, they run as those containers in this Metaflow namespace, and then the last step deploys. Actually, this is wrong. 3 containers into production namespace, which run Two of them run Seldon server, and the third contains some business logic. Again, that Clive have shown you. Let me quick refresher. What we're trying to do during runtime is we are going to take the vector of features, then run a scalar model. Then depending on the output of the scalar model, we may or may not run a XGBoost model as well, and then return a XGBoost output. So there's a little bit of this small pipeline calling two models and then deciding what to do with the result. So in the end, in this production namespace, we will have two containers running scalar and XGBoost models, and then third container there will be running this business logic. Okay, so let's see what's going on in my flow right now. There's last step called tempo is running that is supposed to deploy those containers. And what it does in the end, I should have mentioned this. Okay, hold on, let's check with my windows a little bit. What it's supposed to run is this. So it uses tempo to deploy the production endpoint, then it will wait for it to come up, and it will call predict on it, passing it some features. Naturally, this is usually you would not do this from Metaflow. This will be done from some other web service that is using your machine learning model to, I don't know, drive some business logic, render some buttons, or I don't know, show some ads on the website. But in this case, just to test it, it deploys those endpoints and right away it tries to call them to see if that works. So let's see if that actually works. Yes, my flow has completed. Seldon tempo deployed the endpoints to the Kubernetes cluster, and it did call it and it did return something. So presumably it works. And lastly, with Metaflow, you can also see all this stuff, not only just looking at the console, you're looking at the terminal. You can use Metaflow UI to see how this whole execution happens. So you can see actually, this is right, let's make it bigger. This is what happened. So we had all those steps. There was a start step, then it forked into training a scalar and XGBoost model in parallel. Then it came back together to deploy both of them to Seldon. And in Metaflow UI, you will be able to see all this stuff happening. There's a timeline. And you can also dig into every execution, see the logs, what was actually going on. And you can see what artifacts that they produced, if they're actually small enough to display in a browser. I'm not going to show you gigabytes of data here yet. But for smaller artifacts, you can see they're actually displayed right away. So you can monitor your task execution this way as well. Or you can use your favorite Kubernetes tool. It's all visible there too. And the last thing, I want to check that my Seldon containers are actually running. I don't see them here because they're in different namespace. Here they are. So there are 3 containers running. Those are HTTP gRPC endpoints to serve the predictions, with 1 container running to contain this business logic, like if else, if we like scalar and output, then use scalar, and if not, use XGBoost. And it also runs both scalar and XGBoost models as separate containers as well. That is it. I think I did not forget anything.
Awesome. So we have many questions. So actually, we could just move over to Roman, and then Roman can present a case study how things work at Netflix, and then we can get to Q&A.
Yeah, so thank you. So yeah, my name's Roman. I work at Netflix at the machine learning experience team. Our job, part of our job, is to support Metaflow, which was, as Ville mentioned, originally developed at Netflix, and we still use it. So I won't go over the basics of Metaflow, which Ville covered, and I'll go over some of the motivation again, and then focus, as Ville mentioned, on how we do hosting at Netflix for Metaflow. So the principles are similar to what Seldon. This part, the hosting part, is not open source yet because it's so tied in with some of the infrastructure. It made it hard to kind of extract it. but the principles should apply to what you can do with Seldon, for example. So as Ville mentioned, if you think about Netflix ML initially, you might think that there's a lot of recommendation, which is true. A lot of the initial, the initial ML was for recommendations to basically populate this page. But that's not the only thing that ML at Netflix is used for these days. So there's a bunch of stuff that they use it for, and it's actually been increasing over time. So it started with some of the stuff with on the content side, so like, content valuation, the production schedules, etc. And then it also recently, we've been having use cases where the infrastructure teams, like other infrastructure teams, are interested in using ML to optimize some of their stuff, like on the content distribution network, for example, like where to place certain shows or where to cache things, etc. The machine translation, you have things like you can detect when shots start and end. You can have face recognition. I don't know if you are like on Amazon service, for example, some of the faces are recognized, and then you can have more information about the actors playing. So there's lots of different use cases of ML at Netflix that are not production use cases. And as Ville mentioned, they're usually very varied as to what they're actually trying to do. And so you can't really have very opinionated infrastructure or hosting deployment to serve all these cases. So let's take a look specifically about hosting, about different types of hosting that we've seen internally, like model hosting. So you've done your data extraction, you've done your training, you obtain your model, and what do you do with it? So there's a couple of cases, 4 use cases. The first one, the classic one, which is the recommendation, which I represent here with like the Netflix prize, which is basically like we want to recommend certain things to our users when they come to the web service. So this has a very production-centric use case. It needs to have extremely high availability and to be extremely scalable. You have other cases like batch model scoring, so where you basically have your model and now you want to run it on a bunch of other examples and produce a bunch of batch predictions. You have, this one is more common than you would anticipate, but a lot of data scientists just want to kind of run one-off experiments and see what's going on and what model they can have and what predictions they can get out of it. So it's kind of more of like a snowflake case, but that may turn into something bigger if it works out. So this is how most of the projects start. I have a recollection of a particular example where they were doing things on our compute environment to try to do better bin packing of compute. And it started as a project where they were kind of trying things out, and now it's actually rolled out into production and being used to bin pack the compute on the compute environment. And then the last case is the business critical use cases that are not user facing. So we distinguish these in the sense that the SLA for those can be a little bit larger. It doesn't mean that it needs to fail, but it's not as big of a problem as something on the user-facing side where Netflix would effectively be down. So this is more cases where executives would want to have information about a show and it doesn't work, for example, if it fails. It's not ideal, but it's not the end of the world either. So here are kind of the characteristics of these 4 use cases. As I mentioned, the first case, very high uptime, strict SLA, very high QPS. Second case, background processing. There's very little differentiating logic between different batch processing hosting. Third case, lots of experimentation, lots of differentiating logic, so you don't necessarily want something extremely constraining for the user. And the last case, it's very important, but it has a bit more flexible SLA. So in these cases, and Clive mentioned this earlier about the difference between basically DevOps and a data scientist, you can kind of see that the first 2 cases, it kind of makes sense for a DevOps person to kind of be very involved in designing this. For the first case, because of the performance constraints, and the second case, because there's very little differentiating logic and very little value that a data scientist can bring to that. Second case, the 2 other cases are a bit more interesting because you can kind of see cases where both an engineer would need to be involved and a data scientist, and that's where we've kind of focused our efforts for Metaflow hosting. on these last two cases where it's a little bit more iffy about which person would bring the most value. The engineer would be able to talk the language of how to deploy things, but then the data scientist has a lot of the experience needed for the differences between the code and the requirements. So a model lifecycle, at Netflix these days is you iterate and you develop your model with Metaflow, of course, and then sorry, my notes are a little too big here. You productionize your model training with Metaflow. So by productionize here, I mean that basically you kind of run it on a schedule, so on a pipeline. So you have your data extraction pipeline, and then will trigger your model training, and then produces your model. So that's something that's kind of set up, and Metaflow allows you to do that. In the open source world, there's integration, for example, with step functions that allows you to productionize your model training effectively. But then you want to use and make your model's prediction available, because I mean, it's great to have a model, but if it's not being used by anything, it's kind of worthless. So what do you do with this? So, in the open source world, Metaflow doesn't do this directly. Seldon provides this. Internally, we do have a tool. And why do we have a tool? Because it sounds like, oh, model deployment, that's easy. I just basically have people download my serialized model from S3, and Metaflow has nicely placed it somewhere, and then it can just use it, and that works. Yeah, that doesn't quite work that way. So if you have your data scientist that's kind of happy initially, it's like, oh, I just need people to download my model. Well, then, he starts running into issues fairly quickly. The model doesn't necessarily work in all environments. It needs to have a specific version of TensorFlow, a specific version of this and that, or other libraries. So not great. So he can't really tell other data scientists or other users, well, here's my environment that you need to download my model into so you can use it. And then, so people are like, oh, you can use a certain web service. And then people start asking about GraphQL, which actually happened. People have been asking about how they can have their model access through GraphQL. Data scientist is feeling a little less happy about things. Needs to make it scalable. Lots of users are interested in the model. And then the environment needs to be kept the same across time now, not just across uses. Potentially, the environment, the default environment that people use will change across time, and it needs to be kept the same for the model to work. And then you need to redeploy. You want to do A/B testing. You want to reroute things, and you want to monitor. You want to track and integrate it with the rest of the infrastructure. So all this is kind of getting a little difficult for the data scientists. So we want to make it easier effectively. Because we don't want the first case where data scientists will individually have to deal with all the complexity. They'll probably do way fewer deployments, and they'll be kind of scared in some sense. And we want to encourage people to actually try new things. So this approach that we took is that our team can provide basically this easy to use approach. So what were we looking for when we were trying to provide this approach? We wanted a simple definition, kind of in line with what Metaflow allows you to do for your training flow. So basically allow you to define a web service very simply. We wanted the deployment to be simple as well. Metaflow has Metaflow, your flow run. We wanted something of that same nature that you could do Metaflow, your run, your service deploy, or something like that. We want it to be traceable and reproducible. By traceable, I mean allowing users to figure out where the model came from when they're using it. And reproducible is the part that I was mentioning and that Ville touched on earlier as well, which is the environment needs to kind of stay the same, and you would be able to redeploy and reproduce it later. Debuggable to make it easier in case there's issues, and versionable so that you can have multiple versions potentially running at once. You can run A/B tests, and you can also, it goes into the traceable notion where the a particular version is tied to a particular run that you, a particular model that you trained. So the basic concept is very straightforward. So this is, for example, a Metaflow flow where you have a start step, 2 steps, like Oleg showed earlier. This could be like 2 training, 2 sklearn and XGBoost. Here I just did it. It was just an arithmetic operation, a join step, and then an end step. And to define a web service out of this, the only thing that the user has to do is write a little Python class that kind of looks like this with a decorator called endpoint that says, well, I want an endpoint called show data. And the only thing that you have to do is basically say, oh, I just want to return the value that I got here. So in this case, X. So this is the key part here. The only thing that the user needs to be aware of is what artifacts have been produced. So in this case, the user produced the X artifact, but it could be your model. So the serialized version of the model would be deserialized, and you can then use that to do a .predict, for example. So for the user's point of view, this is great because there's not much that needs to be done. They just need to use Metaflow to train their flow as usual. They produce their model or whatever they need in their hosting side as an artifact, and then they can access this artifact in their web service. And everything underneath it, the packaging, the deploying, et cetera, is taken care of for them. So once deployed, basically, they get a URL, which looks something like this, with a show data endpoint that their users can then call to get the result that they produced here. So going over some of the characteristics that we wanted, we have code versioning. So if you have two versions that get deployed here, you run it once, you obtain effectively a V0 here, a version that says, well, this is the first deployment that you did. If you do it again, changing, for example, some of the values that you have here to 5 instead of 2, you'll get another version that says V1. We'll get different results, and both of these versions can be running in parallel. And you can then promote a class of a canonical version so that your users can be given a single URL that doesn't have the version. So you can have these versions running in parallel. For example, if you want to do A/B testing or any of these other things where you want to redirect traffic to different versions, but you can also have kind of a default version that your users, if they don't really care which version, they just want to get the latest data, they can use that directly. We have the Conda environment support as well. So in Metaflow, as Oleg showed, for example, in the previous demo, you could see that each step was annotated with a particular, with a @Conda decorator, which allowed Metaflow to be made aware of the dependencies that you needed in your particular step. So you can reproduce this exact kind of environment in your web service as well. So it takes a slightly different syntax in this case, but you effectively pass it the same kind of information, pass it the Python version that you would like to use, as well as the libraries. So here, for example, you're using a particular version of Pandas, one of the older ones, a little older one, and you can specify this. And as your web service comes up, it will give you an environment that is appropriate for that. So then your artifacts that you download, for example, X here or your model, can be deserialized in the proper environment and used properly. So this this environment will stick around for as long as your web service exists. So this means that your web service is almost guaranteed to continue functioning, whatever happens to the underlying environment or anything else. One of the key features that our users have been using a lot is this notion of an auto deployment. So as Oleg showed in his demo, one of the steps at the end of the deployment was the tempo step, which basically did the deployment. So we have something similar where it's not necessarily a step, but you can put it kind of anywhere in your step. We have this hosting deployment object, which allows you to do both the deployment of a hosted service, as well as some audit, as well as basically the promotion. So you can kind of do everything at once. And so one of the uses for this is that effectively in the earlier training pipeline that I mentioned, where you have your data that then triggers the model training, that in itself, inside at the end of the model training, you'll have a step that does something like this, that basically says, okay, now I've obtained a new model. I want to deploy this model on a hosting with this web service. I want to check whether it performs properly. So you have a couple of audit calls, and if it does, then you promote it. So effectively, the pipeline is now complete. You'll have your data that will trigger your training model that will, at the end, deploy the model that you've trained, and your users will know nothing about it. They'll just basically keep using it and use the newest model that you've trained. So this is, I think, one of the most popular features that we have. It allows you to basically specify which step you can deploy from. So you can deploy, like, for example, you could technically deploy multiple models or multiple times in the same flow with this pattern, or on multiple branches. So you could also deploy, for example, different types of models for the same thing. Ville also mentioned at the beginning this notion of project, where you could effectively have different users working on the same training flow, but wanting to deploy or wanting to train different things at the same time. So the hosting deployment is also aware of the project. So in Metaflow, you can specify, for example, a branch or something like that when you have a project. So you can say, hey, I'm branch bar, I'm working on this, and then branch foo. And the hosting deployment will be aware of this and deploy actually different services. So you can, again, more easily do something like A/B testing, for example, here, or just deploy different versions of your model, or different models for your same training run. So for example, here you could deploy a model that you're working on, but not modify the production one. And finally, it's well integrated with the Netflix ecosystem, which was important for our data scientists so that they could actually gain insights on their model without having to do much. So if they have the model deployment, we integrate with the typical logging systems within Netflix. So you can use the usual tools that you would use for any other microservice running in Netflix to access the logs that you have and search them and do whatever else you want with them. We also do tracing. So Netflix has, as most companies, just tracing infrastructure to see how the performance is of different calls. So that integrates entirely with it as well. You can use all the tools and the UIs that Netflix has to introspect that information. We collect metrics on number of calls, the duration of calls, etc. So same thing, you can introspect that. That also can lead to producing alerts. So you can say, for example, if your calls are taking too long, you can get an alert for that. All that is integrated as well. And then finally, auto scaling allows the service to basically automatically scale to the number of users. So there's nothing for the data scientist to do to get all this. This is just basically comes out of the box from that very simple web specification that they have. So how do we do, compared to how we started? Well, the simple definition, yeah, it's fairly simple. People like the way you just need to write Python and just decorate it with a single decorator. Deployment is fairly straightforward. It's a command line interface for this hosting deployment. There's no UI yet to do it, so that's something that we might consider in the future. It's traceable, reproducible, everything is logged. You can redeploy it and it supports Conda environments. It's debuggable, but the logs are available, but they're not necessarily easy to extract value from, although given that they're integrated in some of the tools, all the in the UI tools, all the developments toward that, like anomaly detection, things like that, you can use here. And it's versionable, all versions are separated out. There's a promotion notion and then the support for projects. So just a very quick slide on the infrastructure of it before wrapping up and leaving time for Q&A. So Netflix runs on AWS. We use Spinnaker to manage the deployments, and there's a cluster. Our compute environment is called Titus. We use a clone of OpenFast, which is an open source project for function as a service. It was deployed and kind of modified internally, and it forms the basis of what we use for hosting. So the way it works is that there's a control plane that's deployed actually as a function through OpenFast. So the control plane is backed by an RDS instance that basically keeps track of the different versions and other information that's needed to kind of redeploy these things over time. So when you do deploy either through the command line or using the hosting deployment, you'll talk to the OpenFast gateway, which will then talk to the control plane, which will talk to the RDS instance, which will talk again to the OpenFast gateway, and then basically spin up your hosted microservice as well. So everything runs through this OpenFast gateway. So the whole infrastructure is behind this. And you can, of course, have multiple microservices that are deployed, either the same one multiple times for scaling, or just basically different deployments. And then when an executive wants to actually use the microservice, or a UI that the executive is looking at wants to use the microservice, the path is very similar. It goes to the gateway, which then talks to the control plane, which looks up which version it needs to talk to. This, for example, the resolution between the promoted version and the actual version to use. And then goes talk to the gateway to actually reach out to the microservice and respond back. So it's fairly straightforward, but it works really well. And we found that actually just the fact of being able to deploy web services, even for non-ML use cases, although this is very integrated with Metaflow and it works really well, people have been using this just to get web services up because it's so much easier than actually going through the pain of deploying a web service. So thank you. That's the end of my presentation. And I will make Ville the host again. If I can figure this out.
Thanks, Roman. So yeah, now it seems we have about 25 minutes for Q&A, and thanks for all the questions that you have been posting on chat. So what I will do is that I will go over the questions from chat quickly, and then if whoever person wants to chime in with more details about their question, feel free to do so. And then once we have covered the main questions from the chat, you can either just unmute yourself and ask more, or you can keep posting more questions on the chat as well. So I guess one of the first questions in the beginning was from Jacques about having multiple splits. I guess how would you, so when looking at monitoring, how can Metaflow and Seldon work together to test data on many different splits of your dataset? For example, keeping track of a specific subset where you are particularly interested in reducing bias. So Clive, do you have any answer to that?
It depends if you're doing it online or offline, but we do A/B testing, obviously, shadows, so you can use that to test out your data. But if you mean offline bias validation of your training data set, then that's probably a separate thing. We don't focus on that so much, but we do allow online A/B testing. So it depends really what you're trying to focus at.
Jacques, did that answer the question, or no, he's online? But well, we can come back to that if it
maybe to add on Metaflow side, at least that conception of Metaflow doesn't really enforce any specific flow for training or backtesting or anything like this. It actually doesn't even know if you're training a model. You're just writing some code to read from a database, or I don't know, whatever, send email. It's mostly about organizing those workflows and keep track of artifacts, but it doesn't have any opinions on how do you organize your machine learning pipeline. So it should be doable as in, normal Python world. So
another good question by Marcio was that how does this whole stack compare to something provided by Vertex.ai by Google, or maybe Azure's ML offering, or maybe SageMaker? So Clive, how do you think about these serving offerings provided by the big cloud providers?
Yeah, they certainly provide a great basis for getting off the ground very fast with machine learning. I think a lot of the customers we want that sort of vendor-neutral, cloud-neutral solution, and also they want the sort of customization, so they can really dive in and create the particular full stack that they want. So you're generally more limited, which from the cloud interface for what they give with those particular products. And some people are looking for something more neutral that they can have on-prem, maybe switch between clouds, maybe use different clouds at the same time. And that's really fits into what we're doing with the cloud native infrastructure that we deploy. So that would be one reason.
Mm-hmm. Yeah, I guess overall, if you think about the landscape of all these ML ops tools, or whatever you want to call the full life cycle of ML, of course, this is a very new field overall, and most of the tools in the space, including, let's say, SageMaker, they have come out over the past 3 or 4 years, and also it is a pretty fragmented landscape. So there are many kinds of tools, and it's really hard to navigate that. Okay, so what should I be using for what. And like, for instance, SageMaker on the AWS is actually a portfolio of maybe 20 or 30 different tools. And like, of course, for instance, they have SageMaker pipelines that are kind of close to Metaflow, and maybe SageMaker hosting that's kind of close to Seldon. But then like the devil is very much in the details. And like, although everything kind of looks the same when you look at like kind of when you take the 10,000 feet view, I mean, then like kind of if you look closely enough, I mean, there are massive differences, especially in the user experience as well. So what Clive mentioned about the multi-cloud, that's one important consideration. Then another important consideration is just kind of looking at the project. And like, let's say if you are making these evaluations at your company, I highly encourage you to kind of maybe do a simple test project. I mean, take maybe like a school book example, or maybe something that's more relevant for your business. And if you have time, implement that using Vertex or implement that using SageMaker, and then with something like Metaflow and Seldon, and just like compare them side by side. And of course, you will see that there are many, many differences in the details that are like kind of easy to ignore, like when you are kind of just looking at things at the high level or looking at the documentation at the high level. But then when you start actually implementing stuff, I mean, these things become quite obvious and like occasionally quite painful. So that's definitely a good question. Maybe talking about more integrations, there was a question about GitHub Actions, and like, are there any like a specific CI/CD best practices? Like, let's say if one wants to use GitHub Actions or maybe other CI/CD systems for doing these deployments. So, any thoughts about that?
Yeah, I think on that one, I think you probably already even covered. There is some relevant perspectives within the Metaflow example itself. One of the things that we have actually seen in a lot of production use cases is the best practices when actually introducing the capabilities for programmatic automation of deployment of models when it comes to the different stages of the end-to-end ML lifecycle. And I think Romain mentioned a really good point about lineage. So when you have this CI pipelines in play, it's also making sure that the metadata within these pipelines is being passed accordingly at each of the stages with the respective, unique identifiers that allow for that traceability in order for you to know, okay, well, there is this artifact that is now deployed in these 5 different areas. What are the sort of like means to be able to go back? And one of the things that we have been able to see is with things like, GitHub Actions, you're able to instill some best practices for this type of CI out of the box. So ensuring that you have kind of like your Git repo created with all of your, ML training components, but also making sure that when the CI pipelines are sort of set up, they take these things into consideration: the testing, the provisioning of this, identifiers, the metadata of the model, of the artifacts. So it is, again, another sort of like insight of making sure that you take the best practices of that software engineering world, but also abstract it into the context of ML, which does involve much more than just the code. So we do definitely see a lot of very interesting use cases. And in our perspective, in our case, because we deal with Kubernetes, we actually have CI pipelines that run what basically would be kind, which is Kubernetes and Docker. So you can actually run tests of your entire sort of like, Kubernetes stack within each of that CI run. So it's quite interesting to see that, like the intersection between that DevOps and the ML side when it comes to scale.
So there was one specific question like from Christian about the multi-instance GPUs on Seldon. So let's say you have a big GPU, a modern like NVIDIA GPU on your box. And now let's say you want to host multiple different models on that box, and like you want to slice that one GPU for multiple different use cases. So is it something that's supported by Seldon?
Yes, I mean, for that, we use Triton Inference Server from NVIDIA. So they have that capability. So if you're happy to use that server, yeah, you can do all those things you asked for.
Nice. And maybe on the Metaflow side, kind of related topic is that we have been actually working on supporting PyTorch Lightning and multi-GPU as well as distributed training out of the box. So that's a feature that like hopefully will be coming out quite soon. So obviously, as of today, you are able to do GPU training on Metaflow, but I mean, especially when it comes to distributed training, if that's something you want to do, I mean, it's not totally straightforward. And like we want to do that, kind of support that better out of the box as well. So like for use cases that need something like that. There was also a question about the Seldon and custom PyTorch models. And I think that there was some question like answered that already on the chat, but any more color? Maybe Alejandro, I think you answered that question, but.
Yeah, so I mean, I just pointed out some resources. I think it's just echoing Clive's point about Triton. So with Seldon, you have this orchestrator that allows you to leverage the best of breed machine learning servers. So you have Triton, you have ML Server, and with that you can actually serve your PyTorch models, TensorFlow models, Onyx models. And I think to one of the points also from Clive, the key sort of insights that are being explored as well, and there are some really interesting pieces there is on one side that sort of GPU sharing capabilities, but also the challenges of introducing further layers of abstraction, like things such as multi-model serving within a single server, and how that can be actually simplified from an infrastructural perspective, together with the scheduling that is involved, which I actually just saw one of the questions. But yeah, I think it was just kind of like emphasizing what was there. I don't know if Clive, you know.
Yeah, I suppose the only thing I'd add is obviously if you have a standard artifact you can push out to Onyx or something, then you can run it on Triton Inference Server and you'll get the best performance. But if you want to do custom Python code with PyTorch, you can obviously do that in Tempo because that's really just like a custom sort of Tempo environment. Obviously, there's a trade-off then because you're going to be running that inside Python, so it's probably not going to be as optimized. So it really depends which direction you want to go.
Mm-hmm. And Maxim asked a question that can the intermediate artifacts produced by a step, for instance, the output of train sklearn, the model, be reused by different invocations of the workflow? For instance, like if I have already trained the model when running the workflow yesterday and the inputs haven't changed, if I run the workflow again today, will it retrain the model? So Oleg, you talked about Metaflow being agnostic about what actually happens. So more,
yes.
more
so I mean, our artifacts are saved. You can certainly reuse them. You can also, so by default, so maybe I think this question also relates to the point of memorization that some orchestration frameworks provide. They automatically not only save their artifacts, but they will also not rerun the steps if they think that the code hasn't changed and the inputs hasn't changed. In Metaflow, it's opt-in. So in Metaflow, by default, it will run your code just in case it talks to something external, and it's hard to enforce your steps to not have any side effects, but you can use Metaflow resume functionality to basically build a system that starts from yesterday's flow, doesn't like reuse the artifacts up to a certain step, and then runs everything downstream with, I don't know, today's data.
Mm-hmm. No, like thinking about the demo that you showed, like with the tempo deployment, I guess like even if you did the resume, then it would correctly deploy the kind of the unchanged model. Yep, nice. By the way, there was a question about the how dependent on the specifics of a cloud provider it is. So I guess both Metaflow and Seldon now run on Kubernetes. So do you have on the Seldon side any specific dependencies when it comes to the cloud provider?
No, not really. I mean, we're completely independent of the particular cloud provider. Obviously, there are some nuances of running on GKE or AWS or Azure, but apart from that, you basically can run on any Kubernetes cluster.
Like, do you want to add color on the Metaflow side?
Yes, so on Metaflow side, the way we think about it is Metaflow itself is this user productivity, data scientist productivity layer on top of some compute platform, some data store. The first, right now with Kubernetes, it's factually cloud provider independent, except that we also spend a lot of time on making sure it's not only like it theoretically works, but also in practice, we spend a lot of time, for example, optimizing for S3, So right now in production, everyone who uses Metaflow uses it the S3 as a data store or S3 compatible, or a data store that has an S3 compatible API. I believe Google has it, Minio has it. So my point is, so Kubernetes version of Metaflow is not tied to any cloud too much, but we also provide another backend for Metaflow that is optimized for AWS, specifically utilizing AWS batch and containing some specific optimizations that make the best out of this tree. And we'll probably adding more backends as we go. We're currently thinking about Azure, and also spending some quality time on making sure we get the best performance out of Azure storage, for example, when you use Azure and Metaflow together.
So Matt Try asked a question that, like, what types of scheduling are available, and could the schedule be analyzed independently into some DB config file? And I'm not sure if I get the question. I don't know, like on the Seldon side, do you have any idea, or like should we add for more clarifications?
What's being referring to there? I mean, there's obviously things like on the training settings like Volcano. If you're trying to schedule many different training jobs at the same time, you want to prioritize some over the other, do gang scheduling. But I'm not sure that's what's being referred to. On the inference side, unless you're meaning some progressive rollouts, I'm not really sure.
So Matt, if you want to add more color, you can do that now or on chat. So make sure that like we answer the question correctly. Well, maybe meanwhile, like we can check the next question. Are there recommendations for using Metaflow to deploy the pipelines as real-time processes? It's a good question. I know, Roman, like you have been thinking a bit about, at least about the low latency use cases at Netflix. So do you want to talk about that, Roman?
Yeah, so we have, I mean, on the hosting side, I don't know the question on the hosting side in terms of low latency use cases. We have been thinking of basically kind of tying it with a kind of a Flink pipeline, which would get the request and then either look up in a basically a pre-computed cache, an EV cache, and then for things that were not pre-computed, kind of routed to Metaflow hosted service, and respond and populate the cache at the same time. So that's one of the patterns that we've been playing around with on the hosting side of things. So basically having a pipeline that kind of directs it, looks up in a cache as well as make a request to a service if it's not cached.
In open source, we'll also have AWS Lambda support soon, so that will help, at least if you're into AWS native services as opposed to Kubernetes. And then we'll see maybe something similar to for Kubernetes will come up using OpenFaaS or something as well.
Yeah, I guess the kind of the real time is always in the eye of the beholder, like what is real time. So I guess by default, Metaflow is designed for batch processing, meaning that like if your latency is about, let's say 10, 15 minutes or more, that's like where you can really run Metaflow workflows. And then if you want to, let's say like have a lower latency, what Roman was talking about, Flink, you have something like Kafka and Flink, maybe you get like a tens of seconds. And then if you need anything faster than that, anything more real time than that, and then like using Seldon, using like a model serving solution that can give you answer in tens of milliseconds. I mean, that's probably what you want. And then like the idea is that then you can maybe even like call something like a Seldon, like from a Flink application. So I don't know on the Seldon side, do you have any use cases where people like enrich like a real-time data stream by calling Seldon, or like how do you think about those like streaming applications?
And we certainly see people using Seldon in different ways. So yeah, they use it real time, either via HTTP or gRPC for more optimized, or they also use Kafka as well for the more streaming use cases. But also it's also a trade-off at the Seldon level as well. You might be looking at throughput, so you might be looking at adaptive batching, which we support. So you're trying to get increased throughput, but you're happy with like a slightly worse latency. So you've got to think of a lot of different things. And also things like sort of multi-model serving. We're looking at having some aspects of that in the future. So then if you're happy to pack more models onto a smaller number of servers, then you get obviously better optimizations of infrastructure, but also with the trade-off of like some noisy neighbors and stuff. So yeah, it's not a simple answer. You got to think how you want to trade off different aspects of what you want to run.
So I guess Matt clarified here the question that work with the schedule beside the code and like work on the schedule DAG independently in the scope of single pipeline. So I don't know if that makes it clear. I'm not sure if I get the question, but I mean, Matt, if you happen to be online, I mean, feel free to kind of chime in and like make sure that like we get the questions. You can unmute yourselves.
Okay, so let's go live. Yeah, I mean, you have some quite defined workflow, and then you've got some components in your code, and instead of putting it in those annotation in the Python or just exactly in the code, to extract it to maybe some file, and later on you can put some UI on it and work even interactively with those components, for example, this train step, and then maybe changing those or adding some predefined components, like there's some like the scheduling logic, working exactly with that, not bothering with code.
Yeah, that's super helpful. Well, I can like maybe shed a bit light on the Metaflow side. So a number of more advanced users of Metaflow have kind of a configuration layer on top of Metaflow that maybe addresses the point that you are raising. So for instance, like when it comes to the exact schedule or like kind of a resources or like the different branch names, so you can definitely separate them out in a separate config file that you can manage separately. Some companies have kind of a tied that to their like a Git ops, so you have a different branches and so forth, and then you have a config file, and then like the Metaflow decorators, then like the Metaflow has this feature called deploy time functions that you can read those variables as like you're deploying something from a config file, and then like you can like change the behavior accordingly. Now, if you wanted to kind of change the whole DAG like through the config, I mean, that's not super straightforward. I guess technically you could like kind of generate code on the fly, but I mean, I don't think that's super well supported, but at least like kind of that configuration use case like works well.
Okay, thanks.
So, and I guess there was another question by Adars that like, if we are to use custom datasets with some transformations, this process would be running in a container like the start flow as demonstrated in the demo. So Oleg, do you have comments on that? So it's there on the chat as well. But I guess the question is that like, if you have custom datasets with transformations and you want to run it like kind of, let's say as a part of your Metaflow code, it would run as a container.
Right. So you can run transformations as a Metaflow step at any point. I'm not sure. Yes. So yeah. So any Metaflow step code will be running in a container.
Yep. So basically, it's like any Python code, you can have arbitrary code with your own custom datasets and transformations, and then Metaflow will just take care of like a packaging that as a code package that gets executed as a container. So, and like, yeah, I mean, it doesn't have to be necessarily like executing the start. So you can define the workflow however you want as well. And Natasha is asking, what support does Metaflow have for easy experiment tracking, management or tracking? Is there detailed documentation on this available? So Oleg, do you want to answer that question?
I was actually thinking maybe you guys can answer this.
Okay.
Your Netflix experience.
Well, I mean, Roman, do you want to talk about the experiment tracking on your side? So how do you do it these days?
I mean, yes. So experimentation tracking, what people do for Metaflow is they use. Vile's going to kill me, but we use tags, which are a soon-to-be feature in Metaflow open source. You can actually use them right now. When you launch a run, you can tag different runs, but we also have support for tagging post-run. And so people basically use tags to annotate the runs that they do. And then the UI that Oleg showed a little earlier, some views of the UI. allows you to basically kind of filter by tag, so you can kind of see all the runs in a particular experiment that you did. So that's one mechanism, and the other mechanism is Ville mentioned as well, the project decorator and the branches that you can create for that to kind of create. So we have some groups that basically have different branches. They're actually kind of running in parallel as different experiments that they're doing. I don't know if that answers your question, Natasha, or Ville, you want to add anything to that?
Yeah, I guess the kind of a key element there is that there's the new Metaflow UI that's available, so you can actually like see all the runs that are executing. And as Roman mentioned, then you can tag and organize things differently. Then there are also these namespaces, different users get their own kind of a like a set of runs. So there are a number of tools that help you to kind of do the experiment tracking. And there's also the ad project. You can deploy different branches. You can have like experimental branches, production branches, and so forth. So the documentation for that is on the docs.metaflow.org. So there's if you go to kind of go into production section, so there's a section about the ad project and another one about the namespaces that might be relevant. So Clive and Alejandro, on the Seldon side, like how do you think about the experiment tracking? So like, let's say you have a different versions of models deployed. So how does it work on your side?
Yeah, definitely. I mean, we're doing good collaboration with a project from IBM called Iterate, which allows you to do progressive rollouts. So you can create experiments at the inference stage there to just say, okay, I want to test out this model. It needs to have these certain requirements before it can go live, like latency or maybe some sort of business metric. And you can put all that in and run those experiments. There's actually examples in Seldon to run that. So you can set up various experiments at that level. So yeah, it's also important at the infant stage.
So we are like pretty much out of time. So there's I guess like a question of two parts from Maxim on chat. So maybe that's the last one. And then I can, or maybe Oleg, if you want to like put the link to Slack on the chat, so people can definitely join the Slack to ask more questions. And Seldon, I don't know if you have like kind of what's the best channel to reach out to you if people have questions specifically about Seldon, so you can put that on chat as well. Or like you have to send it to everyone. So, but I mean, like meanwhile, I can answer that question that, okay, how large can the DAG submitted to Metaflow be? Number of nodes and edges. So I guess there's no hard limit. The interesting thing is that I guess there's the question that, okay, what's the size of the DAG you submit? And like there are some dynamic parts of the DAG. For instance, you can have these for eaches that fan out based on the data you have. And like now, the largest for eaches, so largest workflows, like we have seen this far, have tens of thousands of tasks. So I mean, I guess that's something that is doable. I guess like kind of we just haven't tried more. So I mean, you start hitting limits with different systems, of course, like as you go much about that. So, and then the next question was that like, what is the Metaflow DAG executor optimized for? So the interesting thing there is that like a Metaflow DAG executor like that comes built in Metaflow is really great for local experimentation and so forth. But then like Metaflow integrates with a number of different orchestrators as you go to production. So for instance, there's an integration to AWS Step Functions, which is a production-grade orchestrator running in the cloud. And now we are working on Argo, which is a Kubernetes native executor. So now, I mean, you can kind of like get a bit different, or you can optimize for different characteristics. So for instance, something like a Step Functions has an extremely high SLA. So if you need to have something that's super highly available, I mean, Step Functions is great for that. But then the kind of a question of like ease of writing the DAG. The idea is that like you use the Metaflow syntax to write the DAG. And then like as you go to production, as you do the scheduling, you can use Argo. If you, let's say, want to stay on Kubernetes, you can use something like Step Functions if you need high availability and you are comfortable using AWS and like maybe others in the future. So. And okay, so just quickly, how might you schedule DAGs on-prem? I guess that goes back to the point of like using, let's say, something like Argo on Kubernetes. So then like if you have Kubernetes on-prem, so then you can use Argo. So that PR is out and like hopefully will be coming out early next year. So I guess like we are like pretty much out of time now. So really amazing questions. Thanks for all the questions. So the links are on Slack. Links to Slack are on chat if you have more questions. And hopefully the recording of this session like will be available online on the kind of the like the MLS website at some point. So you can definitely share the link with your friends as well. So thanks a lot, and hopefully see you on Slack. So.